Hi, I'm Peter Haddock and I'm here with Paul. The last time we met Paul was at Con Expo here with the integrated powertrain we see behind us and the battery system that's literally behind that. And it was a real moment when I said, wow, batteries, come on, what's happening? So you can see that interview, folks, but we've just come into the launch here where you've been talking to me about whole integrated powertrain solutions. You've been talking to me about virtually creating this engine and all the different testing that you've done.
Yep.
And you've also, for me, which is really important, folks, talked about fuel types. So we've talked about hydrogen, we've talked about all of the other different fuels that we've got, HVOs, the diesels, then the other fuels that are coming through, synthetic fuels, etc. as well.
Exactly. Yeah.
We're now in a different era, aren't we, with the whole approach from what you're doing. It's not just all about the engine anymore, is it?
No, exactly, Peter. No, it's really good to have all this here, really show it off again. And yeah, it's a different world. You know, historically, we've just been in a world where diesel's been used for everything.
Yeah.
But as we move forward, we're looking at how we can optimize, how we can be more efficient, how we can be more efficient with diesel, but also looking towards the future, how we can be more efficient, more optimal with all these different alternative energy sources, all these different alternative fuels that are coming on the scene. You know, to start with, the first ones will be the drop-in fuels. You know, the sort of drop-in diesel replacements like HVO, so the hydrotreated vegetable oil, synthetic diesels, etc. By having an integrated powertrain system, we can really optimize the usage of those fuels, minimize the usage of those fuels. You know, typically the drop-in fuels, the alternatives are a little more expensive, so if we can optimize how they're used and reduce the consumption down, that's only going to benefit the customers, only going to benefit the end users in their overall cost of ownership. Looking further out to the future, we've got the alternative fuels, you know, the hydrogens, the ammonias, the methanols, all of those. You know, again, there's a cost impact that's going to come with those fuels in the future. But alongside that, you know, some of those fuels do not have the same characteristics as diesel.
Yep.
You know, the power density that you can get from the same displacement engine on one of those fuels is not the same. You are not going to hit quite the same numbers, you're not going to have the same transient response with them. But have this integrated powertrain system where we're combining, you know, an internal combustion engine with a motor, along with a battery system, also transmissions and other sort of, you know, the power usage parts off the back. We can really try and recover those types of performance deficits that you see on some of those alternative fuels and get a system where the operators can continue to work in the same way as they are working today, but using a fuel that potentially has, you know, no carbon coming out of the exhaust. And an absolutely fantastic technology and something that, you know, we're working on. We've been working on hydrogen engines for a while. Within the enterprise, we have hydrogen systems running today. We've announced projects that we've been working with universities, with industry partners on this, and we're continuing to do so, and we've got more hydrogen projects coming, more alternative fuel projects coming, ammonia, methanol, etc. All of those are in the list and are things we're working on.
And I think what's really important for me about this is it's saying, right, with an integrated powertrain, we're really looking at use cases for the OEMs that you're supplying this solution to. So we've talked about how now we can take that and put battery systems next to it and integrate them. And also, people are talking all the time about, well, I'm always using power mode on my machines. We all know that that's not true. And what was interesting today when you were talking about all of the things that you're doing and the virtual design of things that you're then creating in that virtual world and then making and testing was data.
Yes.
And data is critical, isn't it, for us to understand how to create a solution like this with not only your capabilities, but the things that need to go onto them for the different machine types that you're going to use it.
Precisely. The you know, our integrated powertrain systems, our full battery electric systems as well. You know, understanding how they're going to be used in the real world is super important. And you know, when we've been in a world with diesel where maybe people are filling up their fuel tanks once or twice a week.
Yeah.
Looking to the future, you know, if we look at hydrogen, for instance, you know, the energy density when it's stored is maybe 1/8 of diesel. Right. If we look at battery systems as well, you know, the power density, the amount of energy you can store in a battery versus a tank of diesel is much, much lower. So we need to really work with customers to understand how much do they really need. You know, okay, filling up your tank once a week, twice a week is nice. Really, most customers could manage to deal with filling up once a day or maybe having a recharge mid-shift.
Yeah.
But we're not going to know that unless we look at how the machines are really used.
Absolutely.
If we ask a customer, they typically go, oh yeah, I work really, really hard, you know, I run out of fuel after one day's work. Typically isn't true. And by collecting the real data, we can really understand that. By then taking that data and running it through the simulation models that we have of all of these systems, we can look at the different optimization we do. You know, how big an engine, how big a motor generator, how big a battery. If you've got a hybrid system, balancing all those different things out, and then we can come back to the customers with solutions that really fit their customers' use cases rather than what they think they use. And data's everything, data's key. You know, connectivity is super important. That's why we do so much on the connectivity side. It really helps set up for the future to optimize the systems and actually mean that customers can do the work they need to do in a way that works for them.
And hybridization and integration and things like that are all things that are going to help us step forward towards, you know, our goals of reducing CO2 emissions. Now, when you look at something that's integrated like that, because you're not bolting on stuff, because you're not, you know, sort of being Heath Robinson, let's say, about it all, you're taking out inefficiency.
Yes.
At each stage. So when you're talking about diesel, just the diesel fuel, you're saying, you know, earlier that we're looking at 12, 13, 14, 20% saving in diesel. When you're looking at hydrogen, when you're talking about the expense of that and getting the infrastructure there, when you're integrating capabilities are there as well, you're talking about saving that 1/8 more or that one refueling more. But the other things that it's really about is saying, when we've got a whole solution here, that allows us to design machines that are different.
Yeah.
And they are shaped differently, and we've seen cabless, autonomous machines coming through, where when you've got this kind of capability, it really does change the thinking around what kind of things we can do, doesn't it?
Definitely. You know, you look at the integrated powertrain systems that we have, and you know, here we've got a hybrid system where we've got an engine bolted directly to a motor generator, bolted directly to a transmission. But there's other sort of, you know, could call them hybrid systems. You know, we internally tend to call them like series electric, where maybe you've got a combustion engine tied to a generator, and then motors are remote from that, and you've got power coming through cables to those remote motors. Now, you know, you're disconnecting physically the engine from the power takeoffs. So when you switch between fuels, for instance, switch between diesel or to hydrogen or something like that, those different responses, those different ways the engine would operate is disconnected from the end, so you can keep the same feel. But also look into maybe to a different alternative, and maybe the same machine but often in alternate different ways. You could remove the IC engine completely and put in a battery system instead, because you're looking at electrical power still.
Yeah.
And I think having this integrated view is like not just looking at one sort of individual source, but looking at how we optimize the overall system also gives us a lot of flexibility to be able to change individual components out to protect for the future, maybe start with a diesel one, then move to a hydrogen version, then move to some other fuel we haven't even thought of yet.
Yeah, exactly. Yeah.
And we've protected by that because we're looking at the system, we're looking at the integration, and we're really working with our customers to integrate a solution into their application, not to say, here's an engine, go and do what you want with it. We're saying, well, how can we optimize the overall performance? How do we optimize the power system? How do we collaborate? How do we work together to come up with the best system that's going to use the minimum of whatever fuel we're running on, because there's so many different ones out there.
Well, the other thing from today, folks, which was really interesting, is sometimes, Paul, you've got to build your own little prototypes. And I'm not talking about engines here or powertrains or anything like this. You've built your own telehandler.
Yep.
Back at Peterborough, which they've been hiding from me, folks, until now, revealed today here, and I'm sure I'm going to come and help you hose it down and clean it down, because it's being used by your people in the depot areas and in the whole, you know, setup at Peterborough to move things around in an everyday sense. But what's cool about it, and we heard this earlier, folks, is that actually it can go, because of the integration, into no emission mode as such, to allow you to work indoors and outdoors and have that capability right there. It's great, isn't it?
It is. It's sort of I wouldn't call it a sort of best case secret, because I don't think that's the right way of putting it. But you know, our engineering team, you know, they want to learn. You know, they're inquiring, they're inquisitive. You know, they're curious about things. So they went off and they said, right, you know, we've got this lovely show version, but actually we want to understand how it really works. You know, we don't want to just show things, we want to demonstrate things.
Yeah.
So they went off and built a machine. You know, they took out a 75 kilowatt engine, replaced it with 55 kilowatt, along with a 20 kilowatt motor and a battery system in there, and used it to learn and used it to test, used it to look at some of the simulation things we've done, built it all up virtually first, did the testing virtually, and then moved it into the physical hardware. Then, you know, machine started to be tested. They got some great results off of it. The guys that were doing the testing are like, this is a great machine, so started using it for their day-to-day work. And then they sort of got muddy, got dirty, was being used, and then suddenly we realised there's this great machine there and our customer would be super interested. The hardest bit is getting it jet washed so we can actually show anyone, because normally you walk up to the machine, you get covered in mud because somebody's been using it to go and move something around site or move an engine from here to there or move a bit of equipment. But yeah, it's a great demonstrator. It's really good to show what we can do, and it just shows how sort of inquisitive and curious the team are, and that we don't want to just like talk about stuff, but we actually want to do it. We actually want to demonstrate it. You know, the proof is in the pudding, and we want to show people what we can do.
And I have had a sneak peek, folks, of that area, the secret area I call it, in the Perkins facility at Peterborough, where you're even taking some of the industry's machines and putting an engine system and this kind of thing into an existing machine to show people how your products can actually help their products be better and save more emissions. And it's all about, folks, the critical thing that I like to talk about, which is reducing carbon, reducing our impact on the environment, and challenging ourselves to do things differently. And of course, we've now been able to talk about the big word hydrogen with the team here at Perkins, and we've been able to discover this roadmap that you're going on to change the way in which you're delivering. And I'm sure we'll hear more from Paul and the team, especially when I go and find that telehandler, folks. Great to see you again.
Thanks, Peter.